Hello. This will be the final video of the Redis replication extension, and we'll implement support for the wait command, but we'll actually implement support for these parameters that the wait command expects. In the previous stage, we were not processing the parameters that it expected, and we returned back 0 immediately. We just added a case for this wait command and was returning this 0 hard-coded, but now we need to actually implement support. So I'm assuming you will have seen my previous video where I've explained the entire replication process. I explained this sequence diagram in the previous video, and we'll use this to implement support to implement these last two stages. I'll keep looking back to it, so I recommend watching the previous video. It's a short one. So we know that our handshake is completed. We have implemented the support for handshake, but there is something that we haven't done. When we implemented the handshake, there was no concept of slaves that are caught up, right? So now when our handshake completes, we also need to increment the slaves that are caught up, which I showed to you in the previous video. So let's get to where we are implementing the support for the handshake. So our slave TCP server, it initiates the handshake, and the final step of the handshake is the psync command. All right. The psync command indicates to the master that the handshake has completed. So in my master, in the psync method, I can increment the slaves that are caught up. Right. We need to increment the slaves that are caught up, and I explained to you in the previous video. So right here, we need to increment the slaves that are caught up. And we have that we injected connection pool. We have that, and we can add that. We can use that connection pool dot slaves that are caught up, and we increment it. Okay, so let's see the sequence diagram again. After that, the master will propagate down the set commands, and the set command propagation is implemented, but we were not doing this. We were not incrementing the bytes that were sent down to the slaves. Okay, so in my master, whenever we have this set command, here we need to increment the bytes that are sent down to the master, to the slave, sorry. And for that, we need to actually calculate how many uh, bytes worth it was. We don't have the entire uh, string, the entire resp string to calculate the bytes. So we'll need to serialize this command array into that format. So resp is equals to resp serializer dot parse array, and it takes command and returns back with a what's the issue here. Oh, sorry. Instead of parse, it's resp array. Yeah. And the bytes that are being sent down is equal to uh, this resp err dot get bytes, and we need to increment the bytes that are sent down bytes dot length. That's what we need to do. So now we're doing this at the master level, but we also need to do this at the slave level, because our cache is distributed and my slave can serve as master to other slaves as well. So wherever I am receiving the set command from the master, I need to do the same thing right here as well. All right. Let's have a look at the sequence diagram again. And so there is a slight inaccuracy in this sequence diagram. this set slaves caught up should be after the wait command, because we are recalculating how many slaves that are caught up for each wait command that the master receives. All right. So we do this set slaves caught up equal to 0 in the wait command. So let's get to wait. So here is the wait command, right? So right here, we need to see, yeah. So we are returning back this slaves that are caught up. But what if some commands have been sent down to the slaves and we don't know if they have been processed? So we can safely return the slaves that are caught up only when the connection pool dot bytes sent down to slaves is equal to 0. All right. If that is not the case, we can break. If that is not the case, then we need to actually calculate how many slaves that are caught up. Okay. And so my wait command looks like this, right? So we need to parse this 3 and 500 as well. So let me do that. No, we have that in the command, right? So we need to wait for 500 milliseconds. That's what this 500 means. So we need to start a timer, and I'll use instant for it. Instant now is equals to instant dot now. All right. And then I'll create a new method in my command handler dot wait, and I'll pass the command to it, and whenever we are starting, whenever we receive this command, and then after this I can set connection pool dot slaves that are caught up to 0. Why here? Because we are actually calculating how many slaves are caught up in this wait command. So if we do not so if we haven't called this wait command, we can be certain that we can't be certain how many slaves are caught up. And only after this wait command, the master will send down the repl down to the slaves and will receive a repl act from the slaves. And only then can we be certain that some number of slaves have caught up, and whatever that number of slaves is. So if we receive 5 wait commands, the answer for all those 5, the response for all those 5 could be different. So we need to recalculate, and that's why I'm setting slaves that are caught up to 0 again. So let's create this method in the command handler. All right. And right here, this wait command. So my slave can serve as a master too, right? So in that case, this wait needs to be added to the slave as well, right here. And now that we have added the method in the command handler, we can implement the wait. All right. Yeah. Hmm. So in the wait command, uh, whenever we receive this wait command, we need to send repl get act to the slaves, and let's create that string that we need to send down. We'll use our resp serializer for that. Repl get act star, and the string that we need to send down is, let's just call it get act, and resp serializer dot parse array. No, it's resp array. All right. Now we need to convert it to bytes to send down. So get app dot get bytes, and we also need the number of commands being sent down to slaves because we need to increment it in our master. All right. So we need to wait here for some time, and we are required to wait for command of 1, but it's in string, so we need to parse it to integer dot parse int, and no this will be the number of slaves that we are required to wait for. And the maximum time we can wait for, let's call that time itself integer dot parse int, and that will be in command of 2, because command of 0 is wait, command of 1 is 3, and command of 2 is 500 in this example. All right. So now we can send down this repl.conf get ack string to each slave, and how can we access that slave is slave connection pool dot get slaves. I'll send down this in a different thread. Dot run async like so, and here we need to slave dot connection dot send. So this method expects a string and a byte array as well, but we only want a byte array, we don't need a string here. So this is enough for that, and here we'll send down the bytes. We'll need to surround it with a try catch, and after the for loop we can keep track of the slaves that are caught up in 0, and we'll run this loop infinitely, and if the time has, so if now, so we'll calculate a new instant, and if now plus time is greater than that, if the new instant is greater than now plus time, then we can break out of this loop. All right, so let's write that first. If we can check that with duration dot between, let's call it now, and instant dot now, we convert it to milliseconds, and if it's greater than equal to the time that we received to wait for, then in that case we can break out. All right, and here res can be equal to connection pool slaves that are caught up, and if result is greater than equal to the required number of slaves that are caught up, in that case as well we can break out of the loop. Right. So sending down this command to slaves will happen on a different thread, and then this thread will stop and wait for this many milliseconds and check how many slaves are caught up. If the slaves are caught up exceeds the required number of slaves, that case we can just break out and return. And if we have if the time has exceeded or the slaves have caught up, in that case we can increment the byte sent down to slaves by plus equal to this buffer size. And if result is greater than equal to, if it's greater than required, in that case we'll do a resp serializer dot resp integer of the required number of slaves, and if not we can just return resp serializer dot resp integer of result, however many number of slaves that are caught up. And so we added, so in my repl when the master sends down this repl get ack, the slave responds back with an ack command, right? So this repl master will receive this wait. This wait will send down a repl to the slaves. The master will receive the repl and will respond back with the repl ack command. So my repl method here needs to have this case which I explained to you in a previous video. We need to uncomment it, and right here we can break out, and in the slave ack we just need to check if the number of the bytes sent down to slaves is equal to the ack response, and if that is the case we can increment the slaves that are caught up. So with this we should be good. Let's see if it works. So code built successfully and the tests seem to be running fine. We're good. The important thing is we've already added the support for incrementing the number of bytes sent down to slaves right here in my wait command. In my set command, I am increasing the bytes sent down to slaves. And if that is the case, the next stage, which is wait with multiple commands, this is just sending down a set and it's just checking if we are incrementing the bytes sent down to slaves right here. So we have already added that, so this stage should also work. Let's just read what is required of us. The wait command should return either a specified number of replicas. The wait command should always return number of replicas that have acknowledged the command, even if the timeout expires. The return number of replicas might be lesser than or greater than the expected number of replicas in the wait command. Yeah. So we know that. So the test failed. Let me see what the issue is. So it waited for 3200 and it received a simple string. Am I not returning back in the correct format? Where is the wait command? Resp integer. Received an OK. Received bytes and replica 1 received resp simple string. OK. Why? Expected array type got simple string. Let me debug this issue and get back to you. Alright, so I figured out what the issue was. In my ACK case, I was breaking out, and when we break out, we are returning an OK, but that's not what's required. Master does not respond back to an ACK, so we should have returned an empty string right here. And since it would have been empty, nothing would have been sent down to the slave, but my slave received an OK from the master because we broke out of the switch case, and when we break out of the switch case, we return this, but that's not what required for ACK. So instead we should uh, instead of breaking, we should return from this case as it is, and we should return an empty string. So I'll show that to you. If we comment it out, it should work. Just waiting for the tests to run, and you see now it works fine as expected. So that was the issue, simple issue. Uh, the master, let me show that to you in the sequence diagram. When the master receives an ACK, it doesn't return anything back to the slave, right? The master processes the number and returns back to the client, not the slave. And to the client, we were returning an OK because we were breaking out of the switch case and not returning anything empty. That was the issue. So it worked. Let's see. All right, we're done with the replication, and the next thing we're going to do is implement support for transactions and streams. So stick around. Sooner or later, I'll implement support for these as well. So see you guys in the next video.